Hi, I'm Kevin Savitz. Today is August 22nd, 2016, and I have interviewed Bob Frankston, who was co-developer of Visicalc with Dan Bricklin and co-founder of Software Arts, the company that first published Visicalc. Bob was also involved with the Atari 800 port of the program, which is why I was interested in interviewing him, because this interview was done for Antic, the Atari 8-bit podcast, which you can find at ataripodcast.com, where we have the audio of more than 200 interviews with computing pioneers, especially in the Atari computer realm. But I'm experimenting with doing video of some interviews, so this is the video of my interview with Bob Frankston. Enjoy.
And what's that a dump of
What's that?
on your shirt? It
Oh,
looks
this
like
is
an old Apple II dump?
yes, this is a shirt from Kansas Fest, which is an annual Apple II conference. I wore it in honor of Visicalc and the Apple II today.
So it's like the East Coast vintage computer thing I spoke of last year?
Yes, it's a lot like that, except it's in Kansas City, Missouri, and it's only dedicated to the Apple II.
Not an S100 bus meeting?
It's only Apple II?
You know about the S100 bus in the Kansas Standard?
No, I don't.
Oh, the bus was called the Kansas. For some reason, in one of the Kansas cities, they came up, standardized the bus, so it was the Kansas bus.
Huh. I did not know that. Okay, so we're going to talk about Visicalc, and we're going to go over some stuff that you've probably told stories 100 times, and we're going to hopefully get into some areas that we are a little bit new. So,
Okay?
okay. So, can we start before the beginning, kind of before Visicalc was even a idea? Just kind of give me the prehistory, the setup for how
It
your
depends on
story,
how far back you want to go.
all the way.
I mean, like it started with Dan and I meeting at MIT. We decided one day we're going to go into business. We had no idea what it was, but unlike today, the focus wasn't, okay, I'm searching desperately for an idea. It was, well, someday something will make sense. And then when Dan decided there was no future in programming, he had to learn to become a manager. He doesn't do things halfway. So if you want to become a manager, you got to have a
Wait,
business.
wait, wait. There's no future in programming?
Well, he thought the irony is part of the motivation was Beck was moving the business to New Hampshire in his group, and he didn't want that commute. So the job he got for a year before going to Harvard Business School was a commute to New Hampshire. What can I
Okay.
say? But he was too busy, and I was available, and we both, been working in computers for many years by then. So it was not as if sort of two random people, with no experience. He worked on the DEC word processors, helped develop some of the early word processors. There are all sorts of things people don't realize that intertwine here, because the industry was so small. And I was used to, in a sense, retail computing for end users back from '66. So we had a consumer sensibility coming to his father, the printer. And I think that was part of sort of the way we thought of the effort. So he needed a tool. I mean, once you used to word processing and everything, the idea of a magic recalculating screen, you stumble on it when you're just saying, how come this doesn't do it?
Right.
But the trick was, but it was also time personal computing, and everything was coming together. We originally thought of boardrooms as a target with the actually DEC on the VT100 had room for processor inside. I don't know how many of you people are familiar with the VT100.
Probably some of them are.
Okay, it's a
Yeah.
computer terminal,
Yeah.
and it had a little serrated edge to rip your fingers off when you lifted it. The reason for that is supposed to have an internal printer as part of the DEC computer. But basically, I'd also done a lot of 6502 programming. Things sort of came together. Again, personal software was shipping cassettes on the Apple II, and it came together that the Apple II would be the first target in the 6502. And fortunately, that was a processor I was really up to speed on.
Sure.
So we built our own tools and everything. And the other thing, it was course compiled from MIT's Multic system, which gave leverage. So things sort of came together with the experience, the use of screens, and the view that we were creating an experience. The program is the means. So, whatever it took to make it work, we do. This includes dealing with, there was no excuses. You have to make it work. And, and I did fail to meet my 16K design point, though.
Well, luckily spreadsheets never got any larger than that. So, so when you were designing the experience, I mean, I'm sure you had no idea that that interface would last for 35 years, virtually unchanged in some ways.
Well, first I'll give Dan credit. The nice thing about the split was, since we both understood design and programming, but Dan had actually more of a design sensibility, and he had the time, he was not tied to the code, so he was able to flexibly work on sort of how do you make it look. The original design had, headings below and then moved to the top, and all these kind of elements. And it was pretty basic. So I think it's the reason why it lasted is the basic idea is very simple. That all the graphics and everything sort of elaborate on it, but don't change the basic thing. What people, in a sense, have missed is that, and this goes back, I don't know how many of you people familiar like Emacs, an early editor. The nice thing about Emacs was you never had to take your fingers off the keyboard. You never went to the mouse. And it's very nice. And I think one of the design things we had was you didn't have to look. You can do everything on the keyboard. And that was really made it easy to use. So it wasn't, and the other aspect was the grid on the screen. We thought of graphics and everything. We'd seen demos of high-end graphics. But I think the simplicity tied to the task made it disappear. So you weren't dealing with the character screen, you were dealing with your numbers. So I think that it was that core simplicity and leverage point that made it last.
All right, cool. Well, it's interesting that the headers were originally on the bottom and then moved up.
Well, that was where you went to commands at the bottom.
Sure, that makes sense.
Actually, we're also going to put graphics at the bottom, but because Apple had the split graphics feature. But again, 32K is only so much you can do.
Right, sure. So I read an article in InfoWorld from 1982 that basically made the comparison to like Jobs and Woz. Bricklin was the business Harvard MBA guy, and you were the more technical expertise. And I'm wondering if that's accurate. How you feel about that?
Not really, because Dan could have programmed it, so he was a lot more technical. And I really appreciated we were doing business. So there's a lot more overlap. There wasn't the same kind of split between the two.
Okay. So as we all know, the Apple version came out first, and I believe you ported the Atari 800 version.
I'm trying to remember exactly because I helped with it because by the time we shipped, we'd hired people to do it. And we first was the Commodore PET, and Brad Templeton? He was the kid who helped us with the
nice.
that port. All these names you see, that's part of the fun with the industry being so small back then. And I'm trying to remember exact who did the Atari. I was involved in it. I remember going out to visit Atari, and I remember opening up a door and seeing somebody hanging upside down. Turns out it was the exercise room.
Nice.
And so I got involved in the details. I'm not sure how much of the coding I did at that point, how much others did.
All right. That's interesting. The internet says you did the port, which, who knows?
I don't want to get credit for things I didn't do, but on the other hand, at that point, I was definitely involved, but I'm not sure exactly. Because I remember looking at what I was involved in was figuring out how to do it. How do you adjust it? It was very interesting. The Atari I found very interesting because again, this is memories going way back. It was an attempt to figure out, it seemed more of an attempt to do a real operating system and then backing off saying, okay, we can't move that far ahead. So I was trying to find that balance. And I remember the Chromemco box, that was a test machine. And so all those aspects.
Can you elaborate on the tried to do a real operating system?
I'm trying to remember because I looked at it and the more file system calls and what it was because the Apple II and even the PEC was sort of, you looked at the ROM and their assembly code and you sort of branched into them and did things. I'm trying to remember even on the Apple II how the ROM was mainly for BASIC. So we really didn't depend on the ROM. Matter of fact, that reverse engineer was his disk code. So I wouldn't have to agree to give Apple the ability to terminate us after 30 days. The Atari did have a ROM, so you had to call into it. So I think that was the aspect that these are services in there, and you can see there was more of a file system awareness and things, as opposed to having to write to raw disk records.
Right. So, of course, on the Apple, Visicalc was the killer app, perhaps the first killer app, and on the Atari, not so much.
Asteroids are the killer app.
What's
Literally.
that?
Asteroids are literally the killer app.
Right. Asteroids. On the Atari, Visicalc was nice, but it certainly didn't do as well. And do you have any? I mean, I have some ideas, but do you have any sense of why it didn't do as well on the other platforms?
Well, it did well on the IBM PC. It was just a question of the user base. The Atari, basically, Visicalc, was not. We told some people it's good for home budgeting, but we didn't pretend it was really a home budgeting program. So if you're going to buy an Atari, the odds are you weren't going to be a spreadsheet user.
That's probably true.
For a machine for a spreadsheet, you go with the Apple II or the IBM.
Right. And of course, the IBM and later at the Apple II at some point had 80 columns.
Well, it wasn't just the 80 columns. It was also the disk drive because the Atari had an 80 kilobyte disk drive, the smallest one around. So that didn't help. It was just there were no real accommodations to make it a business user. And the 400, did they sell many 400s?
They did, yeah.
But that keyboard wasn't exactly.
No, that wasn't really optimized for spreadsheeting, I guess.
It makes sort of some of the other keyboards seem very good. Of course, we can discuss the PET keyboard, but that's another story.
So you mentioned you went out to Atari. Can you tell me a little bit more about that trip?
I'm trying to remember too much because they were doing. I remember they doing course development of PDP-11s and everything. That was part of sort of more of a computer thinking than necessarily. I mean, they obviously had the origins much more consumer electronics than Apple. But I think when they went to the 400 and 800, there was also some more attempt to make more of a real computer. The disk drive was on external bus. In a sense, you can think of WAS making things work close to the iron. Atari was a little more corporate in that sense. But,
Sure.
Trying to remember other details beyond.
All right. No, that's fine. It's a long time ago. So you wrote this a little reminisce for Creative Computing magazine in 1984, and you talked about Visicalc a little bit and the National Computer Conference. I thought it was interesting how you said that the personal computers at the 1979 National Computer Conference, the personal computers were off in a little annex because it was kind of like the slums.
Yes.
And you talked about Visicalc to mostly friends and family.
Yes. Well, who's to know?
Who's to know? That's right.
There's still some of that. I was talking about at Google Cambridge a while back, and most of the people who came were from my world.
You gave a talk at the Computer History Museum about Visicalc. I found a webpage where you had your notes up for the this talk that you were doing years ago, I guess.
Yeah, it was a while back. This was a panel, I think.
A panel, all right.
Mitch Capor, Dan Bricklin, myself.
Mm-hmm. And does it? I guess the question is, how does it? Is it weird to have created something that is a just like a seminal part of computing history that really changed the direction of things?
Well, a couple of ways. One, by now it seems normal, but remember the early days. I was also on the Multics project at MIT, and when I was at Microsoft Unity Home Networks, made those happen. So I think it's more that being in the industry from the early days, you're sort of exposed to a lot of the seminal events, get involved in them, and it's sort of once the way I often compare it is once Columbus made that big mistake and survived, anybody who sailed in that direction and didn't die was a discoverer. So I guess it feels normal. It's a strange way.
Yeah, it's okay. Um,
Actually, what is important is to give people a sense of it feeling normal. First, because a lot of people don't feel they can do things, make things happen. And this is why I think home networking is more interesting to me, because that I engineered to happen. Whereas Visicalc, we really didn't expect the success. I mean, I looked at it, it was an alternative to a regular job, and I figured it won't be that much worse. So we were really lucky there. But the important thing is to appreciate the luck factor. So, it wasn't as if, I mean, that's probably a lot of people, especially, dot-com boom days and everything, thought they were geniuses because the first thing they did worked. Well, no, they were lucky. And if they try to do the same thing again, the odds are it wouldn't work.
what do you do today?
Today, I'm actually trying to sort of reinvent the world again. I'm trying to understand the internet's connectivity and sort of what's behind it, what's made it work, and giving talks on this and trying to actually do a company to assure what I'm calling ambient connectivity, because the internet is more about a big idea than a physical thing. So how are things connected? How are your devices connected to each other? How do you communicate? There's a chance to rethink a lot of that. So it's been interesting both to try to explain and understand it and build on it. And I think the experience of Visicalc makes a big difference because, well, it's not just Visicalc. Having been at the MIT group, watched these kids around me do this thing that became the internet, and all these things gives I'm allowed to rethink. I don't have to respect the great beers because I know they're just other kids. And, we had something together. Great. Now let's redo it. It's one way to relate to the Visicalc experience is that the program we shipped was the beta. Never did get around to writing the real program.
Well, what was the real program?
I don't know. If the beta worked, my attitude is the beta should be good enough to go in production. And the internet, current internet is a beta test that's in production. And there's some serious problems with it, like the DNS is fatally flawed. There's just a lot of things. So we need to basically learn from it instead of taking it too seriously. And this is true for a lot of the technology. If you know what how grody it is behind the scenes. Now, one of the important things here, and this mentions in my talk, is important to architecture. That the reason we can get away with a lot of the hacks and stuff I did in Visicalc to make it work is the users were shielded from that. There was an interface, this is going back to Multics, that was distinct from the program. So we can make a lot of improvements and changes while preserving the experience and improving on it. I think that kind of decoupling is a really important part of the technology and is enabled by software. So it's really trying to understand sort of how we can get these rapid improvements without having to break and reinvent everything every time.
Did you have give me an idea of what's an easy rapid improvement that's not going to break everything? What's something that could,
in terms of which?
In terms of the future of the internet?
Well, first we got to get rid of one of my current things trying to explain why layering is a really bad idea in engineering. It's a good heuristic, but it makes you dependent. So you have to view the relationship between devices as totally independent of the lower level protocols and the policies. So we can focus on the two endpoints. And that's really the power of the internet, but it's incompatible with the telecommunications industry, which must basically make money on all of the transactions. This is why you can't just walk around and have things work, but you have to be constantly negotiating with third parties. Please let me communicate. convince them to pay the bill and everything. Devices can't do that. So that's really the issue we need to address to get to the next stage of taking advantage of technology. But we can do it to the extent that we're preserving the illusion that it's only the endpoints matter. We can put whatever shims we want along the path, like whether network address translation, all this other stuff.
What haven't I asked you about the Visicalc days that I should have?
Let's see. You want the strangest machine, but the clone. I mean, there's all sorts of design things we had to do. I wrote an essay on some of the design decisions we had to make. One of the interesting things, and this goes against what I just said about decoupling, is on the IBM, the rule is the experience is number one. So we had to go direct to the iron. And that means CPM try to get in the way and be an operating system. And that we couldn't afford their overhead in the middle of the experience. The Atari, I'm trying to remember what kind of those problems we ran into the Atari. I think some of the problems with the file system disks were a little clunky for us, but we couldn't really program around as much as we'd like. So there's a constant tension. There's the architecture, rethinking the architecture. What's the raw, and this is why Larry's problem, when do we want to go to the iron-based machine to reinvent everything? When do we want to build on abstractions? And that's a constant tension. And Visicalc basically went from, people were very surprised I could write small code, because you don't do that unless you have to. But then, in order to get experience, we had to make it fit and conform to the machines and try to take advantage of the platforms. And I guess part of the reason it's hard for me to say too much about the Atari, as you said, the sales weren't that large. We didn't put a large effort. We got it to work. I think, and this is where the IBM clones failed. They didn't give us action to the iron, so they really didn't become a market to really tune to their machines. And then eventually, when they cloned the machine, instead of just doing a generic MS-DOS machine, then they took off.
Right. Yeah. Cool. Right. I think I have what I need. Thank you very much.
Okay, I enjoyed it, and it is also one of these things by experience is running to the Atari people over the years. Whether it's Nolan, there's Al, and the other people.
Nice.
So it's fun. It's a fun experience.
I bet. Nice. Excellent. Well, thank you so much.
Okay, glad to help.
Have a good one.